Today, we are going to look at expanding, factorizing, and solving cubic polynomials. By the end of the lesson, you should be able to expand binomial products to obtain quadratic and cubic polynomials. You should be able to perform polynomial division and factorize cubic polynomial when a linear function can be obtained using factor theorem. And finally, use the null factor law to solve a cubic polynomial. This is the same as solving for the roots of a cubic function. Now, with the first one, expanding binomial products, let's have a look at an example. Oh, before that actually, let's talk about the general form. We know that the general form of a quadratic function can actually be written as a root form. The first step, let's go from the root form to the general form. Look at this example. All right, how are we going to do this? First, we could actually work out x plus 2 times x minus 3. And we know that expanding it is x squared minus x minus 6. All right, then we multiply the 3 terms by x plus 1. If you like, you can write it out this way, which is x multiply into x squared minus x minus 6 plus 1 multiply into x squared minus x minus 6. Alright, so once you have done that and then expand it, you should collect like terms, and this is what you end up, which is a cubic function. Alright, so what I'm going to do is I have got a couple of questions for you to try. You need to pause the video and actually try the 2 questions and check your answer against mine. And by the way, if you want to do x minus 3 times x plus 1 first, that is fine as well. So you could actually, if you like, try doing that. Multiplying x minus 3 and to x plus 1 first before you multiply x plus 2. But that's up to you. If you like to prove that your answer is the same as x cubed minus 7x minus 6, by all means. Right, these 2 examples, I would like you to pause the video for about 2 to 3 minutes, do the expansion, and then check your answer. Right, these are my answer. So 2 plus 2x multiplied by x minus 3 multiplied by x minus 1 gives me 2x cubed minus 6x squared minus 2x plus 6. The next one, 4x minus 1 times 3 minus x times x plus 1 actually gives me minus 4x cubed plus 9x squared plus 10x minus 3. You can check your answer. You can actually check your answer using your class pad if you want to. If I have the chance, I'll show you how to use the expand function in your class pad. Now, we have learned how to go from the root form to the general form. How did we go back from the general form back to root form? I would like you to stretch your memory back to 4th term last year, when you actually learned how to do long division and of polynomials. You've learned how to do long division, and you actually have also learned how to what a factor theorem or remainder theorem is. So today what I'm going to do is look at mainly factor theorem. So now let's have a look at the next slide. Now I'm going to discuss factor theorem, but before that, if I give you a function fx equals x cubed plus 2x squared minus 5x minus 6. Again, can you pause the video for a couple of minutes? Right, you can check your answer against mine. So I've got f of minus 3 is equal to 0, f of 2 is 0, f of minus 2 is 4, and f of minus 1 is 0. What actually are the significance of this 0? Alright, now let's have a look at the factor theorem. For any polynomial px, the factor theorem states that if p of a equals to 0, then x minus a is a factor of px. If P of A is not 0, then x minus A is not a factor of Px. So let's think about going back to the previous slide. F minus 3 gives you 0. F2 gives you 0. F minus 1 gives you 0. What is this telling me? That this, and this are the factor of fx. So for fx, which is x cubed plus 2x squared minus 5x minus 6, we know that f of minus 3 equals to f of 2 equals to f of minus 1 equals to 0. Therefore, we can actually factorize x cubed plus 2x squared minus 5x minus 6 as x plus 3, x plus 2, x plus 1. Alright, so this is important. This statement is very important. If P of A equals to 0, then x minus A is actually a factor of Px. Now, I am actually going to give you a procedure to factorize a polynomial Px. It could be a degree of 4, a degree of 5, a degree of 6, or whatever. Now, note that for this lesson, I am actually going to concentrate on cubic, which is degree of 3. Alright, so you need to be able to search systematically for a factor. That is when PA equals to 0. So what you need to do is use the positive and negative factors of the constant. Alright, use the positive or negative factors of the constant. If you look at the previous one, which is minus 6, the factors will be minus 1, 1, 6 minus 6, 2, minus 2, 3, and minus 3. So in fact, I've selected 3. That's actually the factor. Alright, then use long division or synthetic division to obtain Qx, which is the quotient of x. Qx is actually the quotient, which is Px after it's divided by x minus a. Now, if it is a cubic, Qx will become a quadratic. Therefore, you can factorize it using your knowledge you have learned. If not, you have to repeat the process for Qx until you can find that Qx is a quadratic. Alright, let's do some example now. Alright, this is the first example. You need to factorize x cubed plus 2x squared minus 5x minus 6. Let's fx equals to x cubed plus 2x squared minus 5x minus 6. Alright, now the factors of minus 6 is minus 1, 1, minus 6, 6, 2, minus 2, and 3, minus 3. Alright, you can pair out minus 6 and 6 and it becomes minus 6. 1 times minus 6 becomes minus 6. So these are numbers that we should try first. Alright, I have already worked it out in my mind, so I know what I will try first. I'm going to try f of minus 1. So if I try f of minus 1, I've got minus 1 cubed plus 2 minus 1 square minus 5 minus 1 minus 6. Note that I always use a bracket. The reason I use a bracket is that I will not get confused with the negative number. Alright, so here minus 1 cubed is actually minus 1. Remember, any negative numbers cubed is actually a negative number. Alright, and then minus 1 square is positive 1. So 2 times positive 1 is 2. Minus 5 times minus 1 is plus 5. And then the constant is minus 6. And you can see that this is 0. So therefore, we know that x plus 1 is a factor. Alright, now let's do long division. If you can remember long division, you should. All right. So what we are going to do is divide x cubed plus 2x squared minus 5x minus 6 by x plus 1. We know that in order to get x cubed, x has to be multiplied by x squared. So we'll have x squared here. X squared times x will give me x cubed. X squared times plus 1 will give me x squared. Now, following the division rule, you know that you need to take away x cubed plus x squared. Now, I put in a minus and a bracket so that I know I am taking away. Minus times positive will give you minus. Minus times positive will give me minus. Alright, if it's minus times negative, it will give me a positive. This step is always a good step to remind you. X cubed minus x cubed is 0. 2x squared minus x squared will give me x squared. And then I've got to bring this down, minus 5x. Alright, so now next, in order to get x squared, I know I got to multiply x by x. So therefore I have x squared plus x. Again, I'm going to put a negative. Take away x squared plus x from x squared minus 5x. So x squared minus x squared is 0. Minus 5x minus x, that will give me minus 6x. Then I take the minus 6 down. Here, in order to get minus 6x, I need to multiply x plus 1 by minus 6. And now we've got minus 6x minus 6. And when you take minus 6x away from minus 6x, that's 0. So therefore, we can write down x cubed plus 2x squared minus 5x minus 6 is equals to x plus 1 into x squared plus x minus 6. You should be able to factorize x squared plus x minus 6. Alright, so now you can see that the two numbers that multiplies to minus 6 and add up to 1 is actually 3 and minus 2. Therefore, you've got x plus 3, x minus 2. This is how you actually factorize a cubic. Alright, so determine one of the factor first, and then do the long division, and then do the cubic factorization. Now, I am actually going to show you how to do a synthetic division. For the synthetic division, we are actually going to use the same cubic. So we use x cubed plus 2x squared minus 5x minus 6. And we know that f minus 1 is actually 0. And x plus 1 is a factor. Alright, now how do we do it? First, we have a look at the coefficient of the x cubed, x squared, and x. So if you write it down, coefficient of x cubed is 1, x squared is 2, minus x is minus 5, and the constant is minus 6. So you write down the coefficient of x cubed, x squared, x, and the constant. Alright? And then on this side, I will write down minus 1, which is one of the factor. We know that x plus 1 is the factor. So now, the first thing you need to do is to bring the coefficient of x cubed down. Is 1. The next thing, multiply 1 by minus 1. Alright? Once you multiply by minus 1, we get minus 1 here. And then we add. 2 plus minus 1 will give me 1. Repeat the same process again. Multiply 1 by minus 1. So minus 1 times 1 is minus 1. And then you add minus 5 plus minus 1. That will give me minus 6. Then again multiply by minus 1. So 6 times minus 1 will give you 6. Minus 6 plus 6 will give you 0. Alright? So therefore, we know that because we have divided by the cubic with a linear, we should be able to realize that this is coefficient of x squared, this is the coefficient of x, and this is the constant. Alright? There's no remainder at all. So therefore, we can write x cubed plus 2x squared minus 5x minus 6 equals to x plus 1, which is a factor, and x squared plus x minus 6. And there you go. We've got x plus 1, x plus 3, and x minus 2, which is exactly the same as what we did for the long division. So you can see that the syntactic division provides you with a quicker way of finding the quadratic from cubic. You can use the syntactic division for polynomials with degree of 4, 5, or 6, as long as you know one of the factors. Alright? Now, make sure that the factor is actually a linear factor before you can do a syntactic division. Right. I would like you to try factorising this. X cubed minus 7x squared plus 2x plus 40. It's up to you whether you want to do long division or syntactic division. I am actually going to show you syntactic division. Now, I'm going to give you a guide. I know 40, there are so many factors. 1 minus 1, 40 minus 40, 2 minus 2, 20 minus 20, so on and so forth. So I'm going to suggest that you actually work out f minus 2. Alright? Let's think about f minus 2 and see if this is a factor. Pause the video for a while, work it out first, and do the long division or syntactic division. Right. F minus 2 is actually minus 2 cubed minus 7 minus 2 square plus 2 times minus 2 plus 40. So minus 2 cubed is minus 8. Minus 2 square is 4. 4 times minus 7 is minus 28. 2 times minus 2 is minus 4 plus 40. So therefore, this is minus 40 plus 40, that is 0. So we know that x plus 2 is a factor. Alright, doing the syntactic division, I've got 1x cubed minus 7x squared plus 2x plus 40. And then minus 2 is the number I want. Alright, so bring 1 down. Minus 2 times 1 will give me minus 2. So now I've got 7 plus minus 2, that gives me minus 9. Minus 2 times minus 9, that gives me minus 18. Alright, 2 plus, oh, it's actually plus 18. My fault. 2 plus 18 will give me 20. And then minus 2 times 20, that will give me minus 40. And therefore, it is 0. So therefore, you know that x cubed minus 7x squared plus 2x plus 40 equals to x plus 2, x squared minus 9x plus 20. Alright, so let me write it out on this side. It's a little bit clearer. X cubed minus 7x squared plus 2x plus 40 equals to x plus 2, x squared minus 9x plus 20. And you should be able to work out how to factorize this, a quadratic. So, two numbers multiplies as 20 and adds up to be minus 9. It's actually minus 4 and minus 5. Now, if you really want to, I will show you the long division again. So let's try the long division again. X cubed minus 7x squared plus 2x plus 40. If you know how to do long division, you can skip it. Go to the next slide. But I'm going to show you again for some of you who might want to do long division x plus 2. So what I want is, I want x squared. X squared times x is x cubed. X squared times 2 is 2x squared. So minus x cubed minus x cubed is 0. Minus 7x minus 7x squared minus 2x is minus 9x squared. So in order to get minus 9x squared, I multiply x by minus 9x. So minus 9x is minus 9x squared. Minus 9x times 2 plus 2 is minus 18x. Alright, take away. So here, therefore, minus plus minus is 0. Plus minus 18 times minus is plus. So therefore, it's 20x plus 40. And we have to multiply x by 20 to get 20x. 20x plus 20 times 2 is 40. Take away, and that is 0. So therefore, you can see that this is actually the same as this. Alright, the next question that I'm going to show you, I actually want you to pause the video completely and do it by yourself without help at all. I will not even tell you what the factor you should look at. Now, I'm going to let fx equals x cubed minus 7x minus 6. This time, for me, I know that minus 1 is actually one of the factor. So f of minus 1 equals to minus 1 cubed minus 7 times minus 1 minus 6. So therefore, I have minus 1 plus 7 minus 6, which is 0. Therefore, x plus 1 is a factor. Alright, so synthetic division. This time, you've got 1x cubed. 0x squared. Now, I purposely choose this example is because I want you to see that if there's no x squared, you need to put a 0 in. Minus 7x, actually minus 7, and minus 6. Don't worry about the x. So, minus 1 is a factor. X plus 1 is a factor. Therefore, the synthetic division, divide by minus 1. Bring 1 down. So, minus 1 times 1 is minus 1. 0 plus minus 1 is minus 1. And minus 1 times minus 1 is plus 1. Minus 7 plus 1 is minus 6. Minus 1 times minus 6 is actually 6. Minus 6 plus 6 gives you 0. Therefore, x cubed minus 7x minus 6 equals to x plus 1. And then x squared minus x minus 6. And therefore, we can actually factorize this. Is x minus 3, x plus 2. Right. you can see that syntactic division is actually a really good way of dividing polynomials. I would like you to try the next one. The next one, a little bit trickier, but I'm sure you can do it. Pause the video for a while and actually work on this. Alright, let fx equals to 2x cubed minus 9x squared plus 4x plus 15. Alright, the factor of 15 minus 1, 1, 3, minus 3, 5, minus 5, and 15 and minus 15. So what I'm going to do is try f of minus 1. 2 minus 1 cubed minus 9 minus 1 square plus 4 times minus 1 plus 15. Alright, minus 1 cubed is minus 1, 2 times minus 1 is minus 2. Minus 1 square is 1, 1 times minus 9 is minus 1, minus 9. Minus 1 times 4 is minus 4 plus 15. And you can see that this becomes 0. Therefore, x plus 1 is a factor. This time, let's do the syntactic division. Okay, syntactic division, you've got 2x cubed minus 9 plus 4 plus 15 and minus 1. Bring the 2 down. Minus 1 times 2 gives me minus 2. Minus 9 plus minus 2 is minus 11. Minus 1 times minus 5, minus 11 is 11. 4 plus 11 will give me 15. And minus 1 times 15 actually gives me minus 15. Therefore, this is 0. So, we know that 2x cubed minus 9x squared plus 4x plus 15 is equals to x plus 1. Now, this is 2x squared minus 11x plus 15. Alright. Now, you actually need to find two numbers which multiplies as 30 and adds up to minus 11. Right. Pause the video for a while and see if you could do that. Right. We should know the two numbers is minus 6 and minus 5. So therefore, if I split minus 11 into minus 6x, minus 5x plus 15, I can actually factorize by grouping. So if I take the 2x out, is x minus 3, and take the minus 5 out is x minus 3. So therefore, this factorize 2 and x minus 3. X plus 1 times 2x minus 5 times x minus 3. Alright, this is how you do it. Now, the next one, again, I'm not going to say anything. I would like you to try it first. The only slight difference is there's a minus 4 in front of the x cubed. Still doesn't really matter. You still should find the factor. In this case, it happens that f minus 1 is actually a factor. So let's try this. So minus 1 cube is minus 1. Minus 1 times minus 4 is plus 4. Minus 1 square is actually 1. 1 times 9 is 9. 10 times minus 1 is minus 10. And minus 3. Therefore is 0. X plus 1 is a factor. So let's do the syntactic division. Minus 4, 9, 10, and minus 3, and minus 1. Bring the minus 4 down. Minus 1 times minus 4, that gives me plus 4. 9 plus 4 is 13. Minus 1 times 13 is minus 13. So 10 plus minus 13 is minus 3. Minus 1 times minus 3 is actually plus 3. Minus 3 plus 3 is 0. So therefore, we know that minus 4x cubed plus 9x squared plus 10x minus 3 equals to x plus 1 into minus 4x squared plus 13x minus 3. This time, I will take the minus out, which means we have minus x plus 1, 4x squared minus 13x plus 3. Alright, now you can actually factorize it by grouping. We know that two numbers should multiply to plus 12 and adds up to be minus 13. So we know that it's actually 4x squared minus 12x minus x plus 3. So minus x plus 1, take away 4x, x minus 3, take away minus 1, x minus 3, not take away, take out x minus 1, therefore it's minus x plus 1, 4x minus 1, and x minus 3. So we have factorized minus 4x cubed plus 9x squared plus 10x minus 3. Now I would really like you to develop the skill of syntactic division. So if you are not sure, please email me. I will actually look up some videos for you or prepare a video on syntactic division for you. Now, let's recall the null factor law. So if we know that m times n equals to 0, n is 0 or n equals to 0 or m equals to n equals to 0. So again, we can extend this concept to m times n times p. So m could be 0, n could be 0, or p could be 0, or all three of them could be 0. So therefore, if you think about it, if we factorize a cubic, what we get is the 3 roots. Or if it is a 1 with a perfect square, it's going to be 2 roots. Or sometimes when you factorize it, you could have only 1 root. Alright? So this is useful about null factor law. What I want you to do is find the roots of x cubed plus 2x squared minus 5x minus 6. Alright, the reason I'm using all this old example is we have already factorized it. We know that x cubed plus 2x squared minus 5x minus 6 is actually x plus 1, x minus 2, x plus 3. Alright, so therefore if we need to find the roots of y equals to this, we equate x plus 1, x minus 2, x plus 3 equals to 0. Roots is the x-intercept, which is when y equals to 0. Therefore, using the null factor law, we know that x plus 1 equals to 0, x equals to minus 1. X minus 2 equals to 0, x equals to 2, and x plus 3 equals to 0, x equals to minus 3. So if you want the coordinates of the roots is minus 1, 0, 2, 0, and minus 3, 0. So you can see that it is really, really useful when we actually need to find the roots of a cubic, especially when we are sketching it. Now, the next one is this one. Y equals to minus 4x cubed plus 9x squared plus 10x minus 3. So we know that minus 4x cubed plus 9x squared plus 10x minus 3 equals to 0 to look for the cubes. And we have already factorized minus 4x cubed plus 9x squared plus 10x minus 3, which is 4x minus 1, x minus 4x minus 1, x minus 3, and x plus 1 equals to 0. Therefore, we know that 4x minus 1 equals to 0, x equals to 1 over 4, x minus 3 equals to 0, x equals to 3, and x plus 1 equals to 0. X therefore equals to minus 1. Again, if you want the coordinate, it's 1/4, 0, 3, 0, and minus 1, 0. Alright, so what I have shown you is how you can change the cubic form of a quadratic, the root form of a cubic to actually a general form of a cubic. Then I've shown you how to perform polynomial division, how to factorize cubic polynomial, and use the null factor to solve a cubic polynomials. So you know that when y equals to 0, x is actually the roots of a cubic function.